So the last part of question 2 is 2H, which is a pretty tough problem to get your head around. And as often with the harder types of problems, it's probably worthwhile actually trying to think about what you're trying to do rather than worry about the calculation and how to solve it. So if we get our heads around the problem, the actual math it's actually pretty straightforward. But again, it's trying to understand what you need to do. So let's try to break this down. So from earlier on, it tells us up here that from this point P1, I can now see a boat at B. So only when I pass this point P1, so I'm on the Ferris wheel, we're having a good time, and at that point we look out and we can actually see that boat B. So from this point P1 all the way until we reach P2, we're having this lovely view of the boat on the water. So we're like, how good's this, right? But then once we pass P2, because obviously the Ferris wheel is turning, beyond that point, we will no longer be able to see that boat because we're turning up and we're sort of at this point here, right? So really, I can only visualize that boat between the point P1 and the point P2. So now knowing that information, really, all I need to do is find the angle here, beta, which is sort of between the lines P1 and P2, sort of that angle there, right? The angle between sort of that dotted line and that P1 is what I'm looking for. Because once I can find that, I can then divide that by 360 degrees, because obviously we know 360 degrees is in the circle, and I can figure out the ratio of the period, because the period is 30 minutes to get around. So if I can find the fraction of the angle divided by 360, that will then give me how many minutes I can actually see that boat and have that lovely view. So that's what this question is actually asking. So for those of you who persisted to actually think about this, it is a tough one, but there is a way through as per normal. So really, for me to calculate this value of beta, because I've got a right angle triangle here, so I've got this right angle in the corner, and this, I know that the little angle here is theta, and the big angle here to P2 is alpha, so therefore the intermediate angle between those two is alpha minus theta. So really, I've got this triangle's got a 90-degree angle, there's my unknown, and there is my angle alpha minus theta. But we now know the value of alpha, and we now know the value of theta from the previous question. So this is actually very easy to calculate. So if that's worth 90, well, these guys are complementary angles. So going back to year 7, right? So complementary angles add up to 90. So well, then the beta and the alpha minus theta share 90 degrees. Well, the fact that I know what these are, well, beta must be 90 minus whatever that is, right? So that's my calculation here. So there I go here. So I know what alpha and theta are from the previous question. So alpha is the 13.67, and theta is what we got from the previous page, the first couple of questions. So it's actually 84 degrees. So basically 84 degrees is beta. So 84 degrees out of the revolution of 360 tells us how many minutes or what fraction of that cycle we're going to be able to view that thing, right? So if my period's 30 minutes, I will time that ratio by 30 minutes, which gives us an approximate figure of 7 minutes, because the question says find the length of time to the nearest minute. Then I'm just going to approximate here my 6.97 to 7 minutes. So for 7 minutes, we're having that glorious view, and we're thinking about good times on the boat. So hopefully that explains some of it. That's probably the longest video that I'm going to make, but hopefully that helps in some way.